Okay, if you didn't watch the first part of the video, I'd go back and do that because we were able to label that middle triangle, and then we were able to find out that that opposite leg was 6 root 6. Now that we know that, we're ready to do sine, cosine, and tangent. We'll start with sine. Sine of angle A is opposite over hypotenuse. So in this case, opposite is 6 root 6. Hypotenuse is 21. I might need to reduce that, but I usually wait and reduce everything I need to at the end. The next one is cosine of A. So cosine of A, meant to color code that. We'll just do that maybe. Cosine of A is adjacent over hypotenuse. So adjacent is 15. Hypotenuse is 21. Once again, I'll worry about reducing later. And then tangent, we'll remember to color code of angle A is going to be, in this case, opposite over adjacent, which is 6 root 6 over 15. And once again, we'll worry about reducing in a moment. Now the other three trig functions. I'm going to go back and worry about the one that goes with sine first. Since sine doesn't have a co, the one that goes with it is cosecant. Or you can think of it that the S goes with the C, or the one with the co goes with the one not with the co, however you remember which one goes with which, or you can put them all on a little card and look back at them. But cosecant of angle A is going to be just that flipped upside down, so that's a 21 over 6 root 6. The next thing I have is I have the one that goes with cosine. So cosine has a co. The one without a co is secant. So secant of A is 21 over 15. And then the last one, tangent does not have a co, so I need the one with a co, which is cotangent. And quite frankly, that's the one that's easy to remember. It matches. Tangent and cotangent, just common sense kind of tells you it matches. So 15 over 6 root 6. And that's what we have for our trig functions. Now, a lot of times you will see these both reduced and rationalized. So I'm going to go back through and reduce them real quick and rationalize. For the sine, I need to look for a number that divides into 6 and 21. I cannot reduce the 6 inside a square root with a number outside, but I can divide both of those by 3. So that'll give me a 2 root 6 over 7 is the simplified form. This one, you see how I have a root 6 in the denominator. I actually end up multiplying top and bottom by root 6 to rationalize and get rid of that root in the denominator. Root 6 times root 6 becomes 6. So I have 6 times 6, which is 36 on the denominator and 21 on the numerator. Now that does reduce. They both divide by 3, I believe. So I have a 7 root 6 over 12 after I divide them both by 3. A little bit of extra work there. The cosine, those reduce pretty simply. 5 over 7, they both divide by 3. And then the secant both reduces nicely, 7 over 5. This one, tangent, I have 6 root 6 over 15. You can go ahead and divide both of those, the 6 and the 15, not the 6 under the root, but that is a 2 root 6 over 5. 2 root 6 over 5. And this one over here, I have to do the same thing to get rid of the root 6 on the bottom. So I multiply 6 top and bottom, and that's going to give me a 6 times 6 on the bottom. And the truth is, before I even multiply that, I could reduce the 15 over 6 and basically say, oh, that's a 5 and a 2 when I divide by 3. So I'm left with a 2 times 6 or 12 on the bottom, and I have a 5 root 6 on the top for my final answer for cotangent. So some students I've met, they like to reduce first and then worry about the square root. Some worry about the square root first, then reduce. Whatever you want to do works as long as you can find all 6 of these trig functions. And feel free to write these notes down and look back at them frequently. I'm going to let you do this last one on your own. The one thing I am going to mention is since A is since A is your angle, this time opposite will be here and adjacent will be there because it's based on touching the angle, not whether it's on the bottom or side of the triangle.